We start our workshop now. I give a brief introduction and then we're going to go ahead with the presenters. So, Thomas Stockholm, I'm representing Qualcomm. I work in 3GP. I'm also working in 5G MAC and a couple of other organizations, which is irrelevant for the details. But in several of these organizations, the issue of energy consumption related to media is an important topic. For example, it's a design vector for 6G. And for example, 3GP has started to look into this into details. What we identified that we would appreciate feedback from the industry to get tangible measurements and inputs from what has been done in research, but also in practical deployment. So hence we organized this session and very grateful to 5G MAC to host this. It's jointly with 3GP and in particular with the colleagues from Greening of Streaming, because they have been doing tangible work over the last couple of months and years. So thanks to Benjamin and colleagues to going ahead. At this point in time, I would like to just go to quick logistics. We have presentations. The presentations are going to be roughly 10 minutes each. And we invite you to basically comment and ask if there is understanding questions. You might also use the chat, which would be excellent. So put questions into the chat. For a larger discussions, we would prefer to then have a bit of a panel towards the end, and we hope we have sufficient time that we can go into more details. So that's what's seen on the agenda. With having said all of that, we're going to record the session. So it's going to be available. The slides will be available. So no needs to basically be nervous and taking pictures or anything like this. I believe we can start, and the first presentation today would be by my colleague from 3GP, Julien Lemonteux from Orange, and he's the rapporteur for the work item in 3GP that deals with media energy consumption in 3GP networks. And Julien, add whatever you feel is important to add for your person, and otherwise just go ahead and present us where we stand. Thank you so much.
Good, thank you, Thomas. So the goal of this first presentation is to provide a kind of introduction of the topic, providing an overview of the problem space and requirements from an operator perspective. So as indicated by Thomas, I'm Julien Lemonteux from Orange Innovation. I'm here on behalf of Orange, but also on behalf of 3GPP SA4, where I'm leading the study on the media energy consumption exposure and evaluation framework phase 2, which I will detail in a few minutes. So to begin the presentation, let's first explain why telecom operator and Orange in particular are interested in this topic. So on Orange side, there is a commitment to be net zero carbon in 2040. So the goal with this commitment is to both mitigate the environmental impact of Orange, but also to adapt Orange to new environmental challenge in order to be well positioned in 2040 or 2050. So you can see here on the right several figures indicating what we are doing. So this is direct work, so we don't need anyone to do this. So we are working on CO2 emission reduction, we are working on device refurbishing, and we are working on electricity coming from renewable sources. So this is the easy part. We can manage it directly without depending from any other actors. But this will not be able to be net zero carbon only by managing this kind of things. On our side, we understood that we will have to work. We have collaborative effort with our suppliers, customers, and also the ecosystem to be net zero carbon. So this is why Orange is particularly active in a standardization organization. So you can see here a list of different organizations. On my side, I'm active in 3GPP SA4, but I have some colleagues working, for example, in ITU or GSMA. And the focus for us, the technical guys, is to work on designing network systems, allowing to minimize the environmental impact, with the goal to reduce the energy consumption, but also with the goal to promote this eco-friendly practice. And we want to do this without degrading the performances and without degrading the quality of experience when we are consuming media. So what is the problem and why media is important, an important thing in this on this topic? So as you can see in the first diagram, the network is not the major part of the digital carbon footprint, at least in France. But if you have a better look on the scope 1 and scope 2, the network is occupying an important part of the consumption. And for an operator like Orange, the network is the main component impacting the energy efficiency. And for us, it's particularly special on the mobile network. And you can see also on this slide, on the fixed network, we don't have any increased consumption on the fixed network. It was a good thing to switch from ADSL to fiber. This clearly helped us to reduce our energy consumption on the fixed network, but we don't have the same thing on the mobile networks. And you can see that our energy consumption on the mobile network, despite our effort on reducing energy consumption, it's still increasing. So the mobile part, the mobile network is particularly focused on our side to produce our effort on this energy reduction. We can see in different organisms, for example, from ARCEP, the regulator in France, or from the ITU or the World Bank, that we have some figures showing the status where the energy consumption here, for example, from the device, the network, and so on. But this is static figures, and we don't have the sufficient granularity, or we are not allowed to have a dynamic analysis in order to act to reduce our environmental impact, maintaining the performances and maintaining the quality of experience. So this is why we are working in standardization, and for example, in 3GPP-SA4. So, and you can see here some insight from the 3GPP-SA4 study. So the study is in progress. It started in the middle of 2025, and the plan is to complete the study in the middle of 2026. So this is my personal perspective. This is not the conclusion of the study, but this gives a good idea of what we learn by doing this study together with all the partners present in 3GPP-SA4. So the first thing is it's very difficult to have precise energy data across the different components of the delivery chain, from the service, from the network, from the device. It's very difficult to have data allowing apple-to-apple comparison on those components. The second thing is about even if we have those data, we don't have any way to share those data across the delivery chain. So if on my side, as a network operator, I'm acting on my network to reduce our energy consumption, but it increases the consumption on the device side, it's not a good thing. And this is not how we will be able to be net zero carbon. We need to share the information in order to be efficient on the overall energy reduction. And this is not possible today. We have some work in 3GPP where there is a component allowing to retrieve the network energy consumption, the energy consumption coming from the network function. But this is not available across other ecosystems. And about this issue, so it's difficult on our side to develop something. It would be better to develop solutions applicable to different ecosystems. So if 3GPP is doing something, but it's not available on the fixed network, it will be difficult to use this information because we will not be able to have those figures, whatever the consumption of the users are. What we also identify is that some mechanism already used for quality of experience, like CMCD or CMSD, could be also relevant to share the energy data across the different components in the ecosystem. So this will not be a good effort, but today it's not possible, and maybe it could be a good thing to work on this. So having this, so in 3GPP, what we plan to do, as you can see on the right, we plan to develop a we have this component, which is the energy information function, collecting all the network energy consumption from the network. And we also have the streaming ecosystems, the video players, which are supporting classic quality of experience functionalities, and which can act to reduce their energy consumption, but they don't have any information on their side today. So the idea, what we are thinking in 3GPP 4 is maybe a component allowing to do the bridge between the information and the video player, which could act to optimize the energy efficiency. Could be a good idea. That's why we are thinking about this component, which is called today energy information application function. And this could be a way to manage this issue in the streaming ecosystem, having this bridge between the data, which could be used by whatever service, by all the services, and the bridge with the streaming ecosystem, allowing to retrieve this information. So, to conclude, so today we are very happy with this workshop because we think it's good to work on this, but it's difficult to work on this organization per organization. As you can see, 3GPP can manage some things on its side, but it's better to have a way to manage the subject in the ecosystem with a solution supported in the entire ecosystem. So this is why we would like to work, and we think this workshop could be the beginning of something, allowing to work on different topics, and we try to have 3 different topics in order to organize the discussion. So the first one is about improving the data collection across all components of the delivery chain. Second one is about developing mechanism for data sharing. And the last one is about the integration in the streaming ecosystem with energy awareness, which could be relevant for the ecosystem. Thank you.
Julia, thank you so much. Thank you, giving both the perspective from Orange as well as the perspective from 3GPP. I think this is very useful. So as we are not like fully pressured by time, I want to check if there's any questions for clarifications or anything related to the content of the presentation from Julia. The best way to kind of interact with me and the rest is to raise hands, and then we just go ahead. Yes, Hordy, please. Thank you.
I have a question, and it's more about what the difference is, or if we know already what the difference is between a media streaming application run on the fixed network and a mobile network would be in terms of data collection, in terms of metrics and so on. If that's part of the study, if you have insight already in the differences.
For the fixed network, we will have components for the radio access network and other things which are not in the fixed network. So the components will be different. On our side, we are using different delivery chains. So we will have to collect the data from both delivery chains and make this usable by the video player. And we will have to be careful on the fact that this should be usable using the same mechanism, whatever the network is. The result will not be the same, but this should be usable by video player in the same way.
Right, the target is a little bit on looking for harmonization of these metrics, so it's a little bit universal across different networks.
Yes, we will have to make this universal.
All right, thanks.
Good, thank you. Again, save your questions, put it into the chat, and we basically collect and come back to some of this while we go. It can also be answered in the chat, so keep the discussion lively. Now we would move on to the second hosting organization, which is Greening on Streaming, and I'm very happy that, first of all, Benjamin and Marisol have prepared a presentation for us today where they stand in very tangible efforts, but also that they have taken on this organization and basically continue to work on doing relevant work in this context. So Benjamin and Marisol, maybe introduce quickly yourself. When you're acting as president, or I don't know what exact term is in the green of streaming. At least you're something like the president, so the very
Yes.
first one.
Okay. So
And let us know where you stand. And I'm very excited to hear more about this one. Thank you.
we will. So I take it I'm sharing my screen and everything. So I'm Ben Schwartz, and I've been calling myself president for over a year, but actually I am technically now president. And so this is news for everybody. We actually physically, technically exist as a French NGO called an association, which has a board and a president, and I am the president of that. We're just finalizing the setup of the French association. We started off as a UK-based organization, hence the term. But I'm based out of Paris, and I've been working with Greening of Streaming extensively for 3 years, on and off since the beginning, which was 5 years ago. So I'll just give you a few words on greening of streaming, some of the things we've learned, how we approach the issue, and I'll hand over to my colleague Marisol in a few minutes, as soon as that's done. So I take it my slide sharing is working. Nobody's commented, so I presume it is. Yes?
Yes.
Yeah, great. Okay, so as I said, we're member driven. I told you we're now a French association. We're really about trying to pioneer energy efficient solutions in the video space. And we're all about evidence based. You know, when we hit the ground 5 years ago, we said a lot of work had been done by the Shift projects and others. And a lot of the data out there was not measured, but estimated energy. So we only work on things that we can actually measure in watts. We have a strong commitment against greenwashing, of course, because that is essential. These are the current members. This will obviously change now that we're a French association. Will be a lot more accessible to more members. I wanted to say that we currently have 5 up and running working labs. We have 2 that are currently dormant, the audio lab and the academia lab, but we hope to get up and running soon. But the language lab is where we really put our thinking hats on and plan for the future and decide what subjects we're going to work on. The language lab writes white papers. We've published about 6 of them. You can see them on our website under publications. There was one on AI, one on power factor, various aspects that we think are critical to our mission. We have a marketing lab which does all the outreach, manages our website and all of that stuff. We have a policy and guidelines lab which published its first guidelines which were user focused. So it's some very sort of pragmatic, simple things like you saw in Julien's slide, that there's a kind of consensus that 70%, so it varies between 50 and 90 depending on the study, but so 70 is a good mid-range percent of the issue of streaming comes from the end device. But we published a simple thing is if you're watching on a large screen, ambient light is actually critical, and we did that based on some data also that Fraunhofer produced a few years ago, that you can basically cut the power by lowering just closing the curtains. So that was one of the things that came out of that. We have a Watt lab, which is basically where all the engineering work and all the measurement work is done, and that's what I'm going to talk about in the next 2 or 3 slides. And finally, we have a protocol lab, for which there is a separate presentation today. So we have multiple diagrams which explain how streaming works, and some of them have up to 40 different boxes in them. This is the high level one. It's how our main technical project, which is called REM, how it's structured. So REM stands for remote energy measurement. And so the two extremes of the thing, from the encoder all the way to the user device, you can see that they're in light green. That's things that have been up and running for over a year. We have a lot of data. I'll give you some sample data points in a minute. The light blue CDN part for the content caching is something we're working on actively. We don't have any fresh data yet on that because, as I said, we only produce our own data. That's what we work on. And of course, the telco part, the ISP part, is still a bit of a black box for us. But we're hoping to open that box a little bit more in the future. So we've been doing this for, I should update that, actually for 24 months we've been measuring now. And here I've just taken 6 samples. We have whole 10-page reports on various of these things. So these are just some snippets of what we've been finding out. So for example, I mean, this isn't a surprise, but at least we have the actual data. We've measured it in repeatable that your home gateway. So if you live in France, your Freebox, your Bouygues box, or your Orange, your Livebox. But basically the device that delivers your internet in your home is typically a 10-watt device nowadays. There's still a few 30-watt devices and a few 5-watt devices, but the average is about 10 watts. And most of them, whatever you do to them, you can't change their energy take. You can leave them empty. They're not doing anything. They're just turned on with one little LED powered. They'll use 10 watts. You overload them with traffic, they use 10 watts. So that is a big problem point, because those home gateways are generally on 365 days a year. In peer-to-peer delivery, we found out, so we have one of our members that works on that. So there's a lot of opacity around CDNs, how much they actually cost. But if you're using peer-to-peer delivery instead, we've actually done the measurement in a repeatable fashion, and we're about at 0.1 to 0.2 watts of extra energy from one peer to be able to share its stream with its neighbor. So this is our fresh data. TV upscaling, for example, you may think, hey, it'd be really cool if I got rid of all this 4K and put it down to HD, maybe. But do know one thing, that a lot of modern TVs, when they receive an HD signal, as they have a 4K panel, they will upscale it. And that typically takes 4 watts continuous. So, 4 watt hours per hour, that would be on many TVs. So if you're doing a World Cup final with 10 million streams and only 1 million of those people do it, you're talking, 4 megawatts added to the grid. This is really, really fresh out of the press, Echo Mode. So this is not published data anywhere else. You're the first people to see it. We've got our first measurement over time. So over a given piece of content, you give it to an LCD TV, see how much power, that would be in kilowatt hours, is used to deliver that piece of content. Then you put the television from its standard mode to its Echo Mode, and we're getting 20% reductions. We're obviously going to put, so that's a very preliminary data. We're hoping to have consolidate that and have a very important data that we can take to regulators and other bodies and say, hey, if people are going to say we're using Echo Mode, they need to save at least something. And before we say that, we're going out and measuring what the actual TVs in today's market are doing. Another aspect of so in the latest in-depth analysis, which you can find on our website, we've got the maths to go behind that sentence, which really it seems easy to understand, but we actually illustrate it with statistics that whatever you do to a piece of content, I'm talking on the device level here, you can use different codecs, you can use different resolutions, you can play with all the technical parameters. Yeah, it will have an energy impact, but those energy impacts are totally dwarfed. They disappear when you compare it to the actual kind of content you're talking about. So put it simply, a bright scene will consume way more than a dark scene, whatever you do with the content. From a technical things, and also a brand new piece of data. For the first time, we've started splitting out the different components at the head end where you prepare your video. So when you separate out the encoder from the packager in the streaming pipeline, you see that the bitrate will affect the energy for both in a similar kind of way. When you raise the bitrate, the energy goes up, lower it goes down. Whereas resolution will change, obviously, the encoding power, but it doesn't actually change the packager at all. So that's just little bits of information that when we say them, you say, yeah, well, of course, that makes sense, Ben, I can explain it to you. But nobody had actually said it like that. And we actually measured it in the real world and came up with it from there. Here's just an old example that I've used many times to show you some. This was from one of our very early hackathons. It's over a year ago, but just to show something that we found really interesting. We still don't explain it a year after. This is comparing H.264 versus H.265. So if you look down here, you can see when from a server, that's exactly what you'd expect. Measuring, sorry, I'm not doing, I'm presenting the different slide. This is measuring resolution, not the thing. So here, as the resolution goes out, you can see the encoder going up just as you'd expect. So to do a 4K piece of content to encode it costs typically in this machine, 60-70% more than to do it with the HD version. Going down to a sub HD version, you save a bit, but you save less. And all this, you speak to the specialists, they could predict it, and it all makes sense. No big surprises here. Here is where the big surprise came for us. This OLED TV here, we're seeing that the 4K content, actually, it's what I was saying to you before, uses significantly less power on that device because it's a 4K panel. It sees 4K in. It just takes the data stream once it's decoded and just puts it onto its data bus. No processing, and that's the internal processing. When you send it lower resolution streams, it does all that work to actually bring them up. And other TVs don't. So sometimes there's no significant statistical significance. Other times there is here. You can see that actually lower resolution is always lower. So each TV technology behaves differently with this kind of thing. This is just to give you an example of the way we work with data. And so with that, I have finished. I've consumed my time. So Marisol is going to take over for the next 3 slides.
Thank you, Ben. Just to give a bit of background on myself, I'm representing here Greeninfo Streaming, and I'm leading the Protocol Lab, one of these exciting tracks in Greeninfo Streaming. I'm coming with a long background on networking. I was working for Cisco for 26 plus years, and currently an independent consultant. But just to bring the perspective of the presentation and what I want to share, it probably links as well with the presentation from Orange at the beginning, right? I just want to give the focus on standards on video streaming with the gap that we probably have today. Probably there are people that don't think the same, right? But and the opportunity that we have ahead, and this is basically the focus of the Protocol Lab, this track within Greeninfo Streaming. The gap that we have today is that standards are quite fragmented on the network domain. Video streaming as a end-to-end use case, if you want to know how much energy it is consumed from a video that you are seeing at home on Netflix, there is no way to measure that, there is a way to measure that. There is no standard that will give you the measurement, right? In an end-to-end use case as it is video streaming. It is fragmented because you have the encoding part, you have the CDN, the network transit in your fixed network and your mobile, and also on the end user devices. If you look at the picture Ben was showing before with the different domains, this is at the end an aggregation of all those space pieces in the big picture, right? And there are several organizations, and this is where the momentum comes, that are looking into standardize such metrics and more from an estimated point of view and from a real-time measurements, that it will make the possibility to make decisions, right, and turn off, turn on new network paths wherever is needed. And here is where Greeninfo Streaming comes, where the aim and the dream, right, from Greeninfo Streaming is to link these network metrics on energy efficiency across the network domains and as well across the organizations, considering as well the regulation. We have another track within Greeninfo Streaming is the Policy Lab, what aims to influence regulations and policymakers. And with that, I want to introduce as well the work that we are doing in another standard organization, another SDO, especially on the ITF, and especially on the working group getting ready for energy efficiency networks. Let me, before that, if you can go to the next slide, Ben. We come with a background. I did join Green of Streaming like 6 months ago, but before it was an attempt to introduce the work that you see here in the slide. It was called eYAN, a YAN-based data model, into this working group, the Green working group within the ITF. And the base idea was to have a standard metric based on the real time to understand how much energy a network device is consuming, and specifically components that are used for the video streaming. This work was sparked, but somehow is linked to the current work on the Green ITF. And this morning, ITF is happening this week in Shenzhen, in China. And this morning I was early today for attending this meeting, and we were presenting the updates on the framework as well as the use cases and the latest on the data model, right? It is going to at the design level, we are defining these YAN modules with all the relationship that could happen between components and devices, mainly covering the networking part. It could be impacting any mobile network or fixed network. At the moment, we are defining this, I would not say the metric, but just to identify which are the components and networking devices that could impact energy efficiency. And one of the use cases that we have been already prioritizing is video streaming. The work is in progress and is quite aligned with the work that it was happening starting a few years back in Green of Streaming, right? If you could go to the next slide, then I can give you the picture of where we are with this Green framework and how it relates to the video streaming use case. That, as you see there, it is presented as use case number 8. But basically, the framework that we are discussing, and probably something that we have to create that liaison from Green of Streaming, or as well between the two organizations with 3GPP work. The point of view might be different, right? But I think all these standards are looking, or they attempt to look from their own point of view, right? But at the end, it needs to be a collaboration. But basically, the YAN data model at the device component level is quite advanced. I would say is covered by the 70%. There are some questions on how the controller might need to communicate with the device from an implementation point of view. And here is where it is left at kind of 20-30% of work. The work is going to start now as well at the controller level, and basically where the video streaming end-to-end use case comes is where you see this G interface at the API service interface, where that API is defined or might need to be defined, right? There is already several APIs describes as well on ongoing work. Not specifically for video streaming, but they could consume from it. But the end-to-end will need to happen at the controller level or the aggregation level, right? One level up to go across domains. And with this, what is really useful, and I think Green of Streaming might be able, we have been already collaborating in Madrid this summer with the ITF on the hackathon as well. But our approach is to have a focused video streaming hackathon in Vienna. Is the next ITF happening in July, and there is collaboration ongoing with Exigence as well from Green of Streaming as well as Green Framework, and we aim to have a good advanced use case for Vienna in this time frame. Then this is still work in progress, and we invite anybody to collaborate as well and provide inputs or just collaboration for that approach. And with that, Ben, I think you want to give a bit more information.
Sorry, I've got too many windows open. It's hard to find the right place to click. Yeah, well, I think we've kind of gone beyond our time, so I'll just quickly take you to the last slide here, which was so to say everything that we said here. Well, most of it's available on the website. We will send the PDF which will be published on the website of this event, and they're clickable links there, so you can actually find all the latest data there. Of everything that we've published, including our data. And there was a great question from Christian, which I answered in the chat, but we can talk about in more length because we need to share more data amongst all our organizations here. So I suggest we put that as a topic for the last half hour. And I just wanted to say that you'll see this slide, you can read it. We've run out of time. But we are open now. We are based in France as an association, so we'll be ready to accept new members with great conditions in the next few weeks. Thank you.
Thank you.
Marisol and Ben, thank you so much. I think that was very useful to understand what you guys doing. Again, I think it's good to continue the discussion a bit on the chat. We pick up some of the questions maybe later. In the interest of time and just making sure that we get through the program easily and have some time for the discussion, I suggest we move on, and we get a bit of input now from a vendor that basically participating in some projects. So Lucas Gregory from ATEM will provide some insights from an encoder or backend head-end manufacturer. And give us some ideas on what they have figured out. So, Lucas, are you ready to share?
Yes, thanks for the introduction.
Please go ahead.
Okay, so I hope my presentation will not be too repetitive given what's already been told in the previous presentation. But yes, anyway, let's start. So my name is Lucas Gregory. I am part of the research and innovation team at ATEM in France. And I will be speaking about a French collaborative project called Smart CD that ATEM is part of, and actually the leader on the project. So I'll start by quickly introduce the project itself for some context. So the goal is to implement a more energy efficient way to deliver video, so a more efficient end-to-end streaming chain. And our work is structured around two main areas. So first, the measuring of the environmental impact of the chain. So we want to quantify the environmental impact of each component in the streaming delivery chain, and identify which part contribute the most to the overall footprint. And the second area is the reduction. So once we understand where the energy is being consumed, we can explore optimization strategies and define relevant ways to tackle this consumption. So in this presentation, I will focus on the measurement part. So we'll start with a quick overview of the system we are studying. So most of you may already know that, but still I will go through it. So a typical streaming workflow involves the following components. So first we have the encoder or transcoder, which transform the video and audio into compressed formats. Then the packager, which prepares the content for the adaptive streaming protocols. And then the content is distributed through a CDN and accessed via a streaming platform before being finally played and rendered on the end user devices. So these components are often distributed across multiple infrastructures and more frequently running on public cloud environment. So the first challenge we faced was simply how to measure the energy consumption of such a distributed system. So to address this problem, we adopted the following general approach. Yes. So instead of measuring the energy directly, we rely on usage, on resources usage metrics like CPU and memory usage, traffic, network traffic, or storage activity. These metrics are either actually collected directly in the data center or on the end devices, but we cannot really collect it on the transmission part of the workflow, which is why we choose to rely on a state-of-the-art formula to compute it. So yeah, all these metrics are fed into an energy estimation model or formula that approximates the power consumption associated with each of the components. And finally, the estimated energy consumption can be monitored in one single monitoring application that's been developed in the project. So we evaluated several state-of-the-art tools in the project. So I'll present three of them. The first one is Power API. So this one is designed to estimate the energy consumption of applications by analyzing system-level resources usages. The measurements provided by Power API are rather fine-grained, done to one process and in real time. But this tool was designed for control environments such as on-premise infrastructures, not for public cloud at all. The second tool is quite known, I think. It's called Cloud Carbon Footprint. It focuses specifically on estimating the carbon footprint of workloads running on public cloud, especially on GCP and AWS. And yeah, it integrates with the cloud providers' billing and usage data to estimate the actual energy consumption and the associated emissions. So it's quite useful for analyzing large-scale cloud deployments, but at the end, the estimation is actually not very accurate, and it's really not real-time. And the last tool we evaluated is called Cloud Scanner. So this tool it relies on a massive database created by a French project called Boavista. Cloud Scanner will automatically scan cloud infrastructures deployed on AWS, for instance, and collects information about the deployed resources and derive a fine-grained power consumption estimation. So this is not real-time, but yeah, it's getting closer to real-time than what Cloud Carbon Footprint is capable of. So beyond selecting the tools, another important challenge was integrating them into our streaming infrastructure. So first, we have to deal with the auto-scaling and dynamic environments. So streaming platforms usually rely on auto-scaling workloads, meaning that the number of running instances can change over time depending on traffic, for instance. So yeah, in the case of the tool Power API, there are actually two components under the hood. One, which is the sensor that monitors CPU and RAM usage of a process or a group of process. And the second component is a formula that interprets the gather usage into an instant power consumption, which depends on the underlying hardware. So in our microservice environment, when a new node or a new pod is deployed, we have to automatically deploy a new sensor and formula to follow the cluster growing up and down. Another challenge is the consistency of measurement and evaluation, especially in an hybrid and distributed environment. So yeah, these challenges are not only about choosing the right tool, but also about how to build a precise and accurate measurement methodology that works in real time and in real operational environments. So our end-to-end measurement campaign have been able to identify the following key points. So first, several factors impact the end-to-end energy consumption, including the number of concurrent clients, the type of generation of the end devices that are being used, or the choice of the video codec, and the type of network in use to deliver the content. Another point is that the main source of energy, according to our measurements, is the distribution, whether it's over mobile or fixed network. So here are the charts that are displayed from a campaign that we ran about 1 year ago. And to perform it, we simulated 1,000 concurrent users using the exact same device. So the top charts are with all the generation device, and the bottom one are using a current so last generation device. So we can see that the main consumption pole stays the delivery, while the decoding and rendering will be lower when using modern devices as opposed to older devices. So to conclude, I will just highlight the 3 main takeaways. So first, measuring the environmental impact of streaming workflows in the cloud is really challenging. This was also what the previous presentation depicted, I think. Mainly because the direct energy measurement is not available. The cloud provider will not share this information, and it's pretty hard to evaluate it given the fact that the workload is running on a very abstract layer of a stack. Second, existing tools such as Power API or Cloud Carbon Footprint and Cloud Scanner provide a complementary approach to estimate the energy consumption. So our choice in the Smart City project was to use all 3, depending on how and where the workload is deployed. And finally, the measurement is a necessary first step before implementing effective optimization strategies. So now we've had the opportunity to set up this end-to-end measurement solution. We have already started working on ways to tackle the energy consumption. So if you are interested in learning more about our methodology, or if you would like to explore the solution that we've been testing and to reduce the impact of our streaming chain, well, just please feel free to contact me or any other partners of the project that you can find on this last slide. Thanks.
Lucas, thank you so much. Very good to get some practical insights and having some data. I think it's always good to be based on collected data. So let me check. Is there anything people would like to urgently discuss? Have questions for Lucas, and it's we want to address now. Again, I invite to use the chat. Hori is also collecting some data there. There's a question on open source tools freely available, Lucas. So maybe you want to speak to this one quickly while I prepare for the next speaker.
So to answer quickly, all 3 tools are open source and freely available. To answer John's question in the chat.
Yes. Okay, good. Then let's move on, and we have another set of research project but Christian is very much involved in streaming operations. He He was for quite some time CTO of Bitmovin, or maybe still is. I don't know exactly. Christian will confirm, but he's primarily at the Alpen Adria University in Klagenfurt. And they have run a couple of projects within the lab and also, I think, in collaboration with others. So we are looking forward to hear what we have. So, Christian, the floor is yours. Go ahead. Thank you.
Thank you. I hope you can see the slides and hope you can hear and see me well.
All good. Thank you.
Good. Thank you. I just had made a very brief introduction about myself. So my main job is still at the university, but of course I'm co-founder of Bitmovin and still involved there, and still help a bit in terms of research and standardization. Unfortunately, in the last couple of years, duties at the university became more and more overwhelming to me, and I'm swamped now with administrative work and teaching, as you might expect here. Anyway, slides will be shared later on, so I will not much, introduce the topic again. Maybe, if you want to come and join here, my office is here, just sitting here, and we have a nice campus. Consider this as a midterm ad, as you know from video streaming. Today, I give you a quick introduction and then some technical topics like energy-aware bitrate ladder construction, adaptive bitrate algorithms, taking into account energy consumption. Bitmovin was part of the EcoFlow project, which is an IBC accelerator programs. And at the end, I conclude a bit on metrics for decision taking with some conclusions at the end. I don't want to spend too much on that introductory slides because the previous speakers already introduced and motivate the need for doing some work here very well. Just to be very short, here the internet traffic increases, also contributes to global greenhouse gas emissions, and also video traffic is increasing. It's like more than 60 on other slides I have seen more than 70-80% of the internet traffic is video. So the idea is to do something here and provide our contribution also in terms of the energy consumption. In that, we produce quite a significant number of research papers, like 25 have been identified. We have some patents and industry-oriented publications. We even have a Best Student Paper Award at NIB last year, and actually the author, Mohammed, is here. In case you have any detailed questions, he might be able to answer that. And since the question was in the chat, there is lots of our tools are open source, and you have public data sets which are summarized at the end. Good. Where do we do our work? So we do basically everything except the network. So as you can see in here, we look into the encoder and the bitrate ladder construction. Then networking component we leave untouched, but others have done this, as you have seen in the slides. And then on the client, we look into like the adaptive bitrate algorithm that, as you know, selects the segments of the right representations depending on network conditions, and taking also into account the decoding energy consumption at the client. Our contributions can be clustered into various categories. I cannot explain everything because I don't have so much time. And Thomas, if I take too much time, just please just stop me, because anyway, slides contain too much information, and people will be able to get that out. The first aspect I'd like to present briefly, and our findings, is something where we investigated the role of the preset selection in per title encoding with respect to quality and sustainability. And what we found out is that if you look here on the right-hand side, on the energy consumption with increasing bit rates and lower or slower presets, as you can see here, the energy consumption increases significantly, while on the other hand, if you look at the quality in terms of VMAF, quality difference is quite very small. So the idea here was also to take this energy consumption into account and come up with means to improve preset selection, provide adaptive preset selection in a per title encoding settings to increase the energy savings, which are pretty high, and quality loss is also not that high. So that's like a vital tool on improving how you encode your video on the server side. if you do this somewhere in the network, it's probably about the same. Another work item here was to have a real-time capability of that on constructing this bitrate ladder for live streaming, taking into account special features. I will explain these features from the tool, which is called EVCA at a later stage. That based on that, we identify about the complexity of the content, and based on that, we look into some candidate lists which are used for the prediction based on the tunable parameter tau. That is the difference in terms of the quality that makes sense for the streaming case, and then the resolution section again by a tunable parameter lambda here, and an energy consumption lookup table that we have built before. We are able to build the bitrate ladder depending on what are the input requirements here. And then the idea here is to have a per title streaming approach, also taking into account the energy consumption. As you can briefly see here on the last column, is that, you know, in terms of the VMAF, it gives you like a Pareto front that isn't known from the traditional per title encoding, and then also takes into account energy consumption for the different for the bit rates, and then also for the different resolutions which are shown here. Also taking into account the frame rate, I forgot to mention that. So we looked into various dimensions here, not only bit rate, resolutions, frame rates. There is also some other works looking into bit depth that could also have an impact here. So that is something that could be also done on the encoding side and on the bitrate ladder construction side. On the client side, we developed eVish. We had the Vish ABR algorithm that basically defines a total cost, which is then providing the basis for the bitrate selection on the client side, taking into account the so-called data cost, which is related to segment bitrate, and the throughput, which is offered by the network, the buffer cost, which is how much data you have in the buffer, and then also taking into account the quality and kind of instability, how often you switch between the different representations. And we now wanted to extend this by the energy cost. So you have this kind of formula behind all these cost functions. You have another formula that then takes this into account, and with this total cost you could determine, and you could have a ABR algorithm that then in our preliminary evaluations could improve. On the other hand, we were even able to improve the QE and also reduce the energy consumption on the client side. But again, very preliminary work on that, and still it's a bit, be careful with that. But in the paper of Mile High Video 24, we had some further details here. Yeah, now I want to briefly talk about the EcoFlow project. It's an IBC accelerator project. Unfortunately, I was not personally involved here. Bitmovin was involved there with many other companies, as you can see in the logo above. It's related to end-to-end optimization, both encoding, delivery, and the playback. Energy consumption was a main issue. They had 2 iterations of the EcoFlow projects, and I think a third is in preparation for this year's IBC. But interestingly, one of the key learnings is like the first bullet point, like this measurement and benchmarking is very hard. And I think this is also what previous speakers already presented. At least this is what I heard. It's due to the high variability. You have lots of heterogeneous devices out there, specifically on the client side. And this is very difficult to access here. They identified some high impact areas, which I am not able, unfortunately, not able to find out, and but should be able to provide them at a later stage. But of course, real world validation is essential, and it could be something really that drives the innovation process here. Good. Now I'd like to switch a bit to some of the metrics. that we have been using on, and one metrics I mentioned is already video complexity, and there are like 2 or 3 versions. One is the existing one is spatial temporal information that has been standardized by ITU, and spatial information is like Sobel filtered edges, which captures texture and structural details, whereas temporal information looks into frame differences and captures motion and intensity. It's simple, it's standardized, and like the baseline that we have used and wanted to further improve. A few years ago, we came up with the idea of the video complexity analyzer that is derived from DCT coefficients, and it measures also texture and edge strength, and we also have a temporal metric that looks into these energy transform domain energy across the frames. We realized that by doing so, it has a is a bit simpler to compute. We also realized compared to the existing SITI implementations, which are not optimized, our implementation was already in the beginning a bit faster, and it also means if you have higher values here, you have also higher encoding complexity. And then the last improvement, actually also done by Mohammed, who is here also in the audience, has even improved to what is called their spatial and temporal complexity, which gives also a higher correlation compared to the previous metrics when we compare this to the baseline. Good. VQM for Haas is another metric. It's like a real-time quality metric. Focus here was on HEVC video. And what we have done here from the original video, we have used some video complexity metrics like I've presented previously. And then to the video encoder, which produces various representations, we do the same. We get the metrics here, plus some encoding statistics that we got out from X265 here, some quality that also the encoder produces, and then we used regression models, linear and random forest, to predict the quality score and calculated Pearson correlation coefficient to like VMAF prediction or like P1204 prediction. We also compared it between to the MOS scores on a data set where the MOS scores were available, and in all these cases we got very high correlations, which made us confident that this is something useful, or this approach is something useful for the future. Okay, another metric is the relative decoding energy index. This is just one paper that we had at ICIP, where the goal is to normalize the decoding energy based on rate, frame rate, and the quantization parameter compared to a baseline, and try to make this device-independent metric for cross-platform comparison, and also enable an energy-aware adaptation. There is then also a model, again, based on the complexity metrics that we have defined, again, some regression models, which gives a very good prediction results. Unfortunately, then students disappeared and we were not able to follow up on that further, but probably also worth mentioning and showcasing here. Good. I think, yeah. Finally, there is a VEEP, which is a video encoding energy and CO2 emission prediction, where we take into account, again, different information, again, video complexity features, but also the type of the AWS EC2 instance and the encoding parameters like the codec, bitrate, and resolution as inputs to produce to use, again, regression models to predict the energy consumption, and then we utilize the CO2 calculator based on so-called carbon and intensity based on a CO2 data source. That's a big database that has then carbon intensity measurements for data centers for different countries. It's like a database lookup for a certain geographic region for which then the CO2 is calculated, again, validated using regression models, using based on the existing data set that then confirms also the accuracy of this kind of approach. And I think finally, before coming to the conclusions, there is something which is more on the communication part and a bit related to what others presented today. It's called receptive, where the goal is to optimize both and energy consumption by coordinating what the ABR is doing and probably also what on clients you do in terms of neural enhanced streaming that basically refers to tools like a super resolution on the client side. So assume you get this lower resolution content stream to the client and upscale it with some AI mechanisms on the client side. Sometimes that could be beneficial, sometimes not. And in this case, we communicate using CMCD and CMSD additional data, which is kind of listed here, to a recommendation service, which then provides updated recommendations in terms of what is the recommended representation ID and potential SR upscaling factor based on information that is provided in terms of which device type is available, what is the actual device resolution to be used, what previously has been selected in terms of representations by the ABR client, and so on. And in this case, we give some recommendations to the client that the ABR might take into account or not. This is part of a PhD thesis of Daniele, if you're interested in that and how that works in detail. So with the conclusions, what are the key findings? So you have an energy quality trade-off. Sometimes small quality reductions can still yield substantial energy savings. You have end-to-end optimizations that needs to be done, as pointed out by the delivery chain. There are like complexity metrics which enable, getting this information quickly out of the content and also offering real-time support. They work in real time and with minimal QE impact. In terms of standardization practice, I think previous speakers have said this already. We need to try to integrate them into encoding workflows, similar like quality metrics, like for VMAF, BSNR, SSM are currently done right now. EcoFlow I mentioned, but maybe a bit more interesting is, okay, what are still the problems or the challenges is in terms of measurements and benchmarking. It's really difficult to measure and compare across different devices and systems. You have software, hardware components. Previous speakers presented this in more detail. Lack of standardization has been mentioned already. Limited workflow integration, so it's not yet the first class optimization target, unfortunately. But on the other hand, we realize that there is a linear relationship to runtime, and if you reduce runtime during the encoding, it might also reduce the costs, which could be a benefit to invest into this as well. Results sometimes depends on content, devices, and for ML, you need lots of tuning, which could be problematic. And it needs, of course, more real-world, large-scale evaluations, which we have not yet done so far because that all has been done on an academic level. Many people were involved in this, which I'd like to acknowledge here. That's why thank for your attention. Some advertisement at the end. And yeah, there are open source tools available on our website. Sorry. And then there are also data sets available like the MVCD multi-dimensional video compression data set that has lots of records and then also has lots of for encoding and decoding energy consumption that might be useful for here as well. I promise to provide the links. I'm still not done with the slides, but that will come at the end. And with that, I would like to give back to Thomas, or if you have any questions or comments.
Christian, thank you. Very comprehensive. Let me check if there is some immediate questions from anyone. Richard.
Hello there. Can you hear me okay?
Yeah, it's good.
Great. Thank you very much for the presentation. It's very interesting. We saw quite a lot here about measuring the energy consumption of video, and we haven't really seen anything about the energy consumption of audio. I just wondered, do you think it's so small and negligible that it's okay to neglect the energy consumption of audio encoding and distribution, or is it just something that's not interesting because there's typically no adaptation between different bit rates in a ladder for audio in the same way that there is for video?
Yeah, good question. We haven't looked into audio because we are more the visual guys, so that was not on purpose, and it's not about neglecting because it is so small and so on. It's just our main focus was on video. But yeah, I mean, probably it's also good to include that. I actually have no details about any of the differences here, or how big the differences are. Still, just we haven't done it, but this was not, our main focus was just video. That's the main reason.
Yeah. So it's impossible to say if it's 1% of the total, 10% of the total, or
yeah, right. I just don't have the numbers. Yeah.
Okay. Thanks.
Okay, Ben.
Yeah, just on that subject, of course, that's something we've been wondering about, and we're trying to start a hackathon on audio, and so we've been doing some preliminary stuff and haven't been able to check anything. Our initial inquiry was into volume. Could the user set volume have any kind of impact? And for now, the issue is to try and find a piece of content that's both representative of real content, because we always work with real world stuff. That also it has to be very specific. It has to have a very, very flat energy line in terms of the video component, whereas the audio component would move up and down. And I don't want to create a fake gray screen or something, because then we're no longer in real world examples. So anyway, we did some trials. And it was in the noise, basically, everything we could do by changing the audio. I was talking about producing the audio. I don't know whether the question was about the production of audio or about the processing of the audio stream. That's another topic.
Okay.
Yeah, thanks.
Good. I suggest we move on, but maybe come back to this broader discussion as part of the panel at the end. Thank you again, Christian. Stay here, so we have probably more questions later. We would move on with another set of results from a project related to green streaming from Martin from Fraunhofer. And so we're going to have now a series of Fraunhofer presentation. But Martin, are you ready to share?
Yes, I'm ready. Trying to.
Excellent. Welcome. And please go ahead and maybe do a quick intro to yourself as well.
Okay. So let me. I hope you can see my screen right now.
Yes, it works perfectly. Thank you.
Okay, great. Thanks. So let me move this box away so I have the full view. Okay, so yeah, thanks for having me here on this workshop. My name is Martin Lasak. I'm with Fraunhofer Focus, based here in Berlin, and we are a research society. Some of you maybe know us from projects. So we do a lot of projects related to media. And yeah, one of these projects is green streaming, which I'm working on. So we are in a third year right now in this project. And yeah, I would like to share some results and some insights out of this project here. Okay, sorry. Yeah, so green streaming, yeah, so as all the very interesting presentations so far said, yeah, video streaming itself, it's very very important in our everyday lives. So it's getting more and more yeah, relevant in terms of looking into the whole chain and analyzing the yeah, components there in terms of efficiency. Yeah, so for sure we have to make sure that the components are operated in a best mode in terms of usability and user experience, but on the other hand as well, energy preserving, yeah, and in the end, yeah, not impacting our planet too much. So these components have to be analyzed on the one hand, yeah, and then measured. This is the goal of this project as well, to generate numbers, yeah, and then to generate automated, adaptive, self-learning, optimized video streaming, yeah, for a better operation of the whole chain. That's the core idea. This is what we wanted to achieve or will achieve. And yeah, we have a consortium for this in this project. We are leading this consortium. Have strong partners on our side for each of those stages in the supply chain, yeah, from production over encoding, packaging, distribution to playback side. And yeah, people have expertise in those areas. So we are tackling a little bit the playback side since we have some experience on yeah, video players. We have a TV lab, which we are conducting tests and measurements and so on. And we have associated partners supporting us and yeah, taking the results and testing the results, the insights in real life projects. So to explain a little bit the ultimate goal here of the project. So by collecting data across the whole steps of the streaming workflows here and value chain, we take this data and yeah, learn from this data, of course, and yeah, produce models to predict yeah, energy consumption of different workflows. Yeah, this is quite challenging, yeah, because we have of course, this is relevant to have the insights how much emissions I have. Yeah, so we are, as Ben already said, watts is our currency. Yeah, so because emissions is the derived value. So once we have the watts measured and we have a good estimate on the components, how they perform and how the energy consumption is, we can derive, of course, the emissions as well from it. So what are the challenges here across the whole chain? There is, it was mentioned already, there's a lack of standardized measurement methods. Yeah, so the access to the consumption values is quite hard. Yeah, so of course we can measure black boxes. We can externally measure electrical power usage of individual boxes. For some boxes, it's harder than for others. Yeah, so if we think about networks, 5G networks, and so on, it's quite challenging to measure the consumption during a streaming session. More than even if it's idle or in any other operation mode. So nevertheless, we have done this. We have lab setups with 5G setups measured the values here as well. So yeah, let me move on to the next slide, maybe because it's for the audience here very interesting to see that there are, of course, advantages for consumers as well. Yeah, so a reduced electricity bill in the end is maybe one of the nicest effects here. But of course, for the business involved companies, there's a lot of opportunities here, advantages as well. So cost reduction, of course, yeah. So we all want to save energy, but in the end, saved energy means reduced electricity bill, means less money spent on the components. So there are different of yeah, other aspects which can make, for example, enterprises more attractive, yeah, to customers if they are energy efficient or in the end CO2 neutral. Stuff like this. This is quite important. But there are as well legal aspects to this. Yeah, if broadcasters or streaming services are at some point then obliged to provide numbers on their eco footprint. Yeah, so that's one of the goals of the project, to see if this is even possible to have a model that can predict those numbers that can be then used in products like CO2 calculators to provide numbers that can be used for reporting. Yes, let me move to the measurements we have done and what we have done to get the numbers. So Ben has already said a lot about TV measurement, and so we started as well on big TVs because initial measurements showed that they consume quite a lot compared to other end devices, of course. But this is quite complex scene because we have very different modes in which a TV can be, and each mode affects the consumption very differently. Yeah, so there is many parameters and many variations you can set a device into, and then if you measure, you will have different numbers. So this is quite complex situation because of the dynamic nature of the data. Yeah? We have a device that acts differently at the daytime than at nighttime. In recent measurements, we even realized that the content streamed has a different value of brightness during nighttime than daytime. So this affects as well. So there are different device settings that influence the energy consumption, and things like picture modes, picture enhancement algorithms, and of course the echo mode, which can be turned on, turned off by the user. And this is maybe one of my most important key messages for this round here, because this was and still is a very tough challenge for us, getting reliable and good numbers in the measurements. Many values cannot be accessed programmatically. So this has, of course, some reasons due to privacy and things like that. But on end devices, for example, it's impossible currently in many applications and environments to get the information if the user has turned on or has turned off the echo mode. Yeah, and this would be good to have this information to predict the consumption in a better way, for example, or give the users context-based suggestions to do so. Okay, so how we approached the data collection for this project. So we combined real energy measurements, using power meters with streaming metrics. So we had already solutions for that in the past, and our goal for this was to automate those measurements, and create a reliable data set which we then could build upon. And so we defined a triplet, consisting of 3 classes of attributes. The first class is content attributes, everything which describes content. And in Christian's talk, we saw that there are tools that can be used to detect the brightness of the content, the spatial and temporal information of the content. And this list isn't even full here. So there's very few examples of parameters which describe content. Then on the other hand, you have device attributes, which can be, for example, the panel type used, of course, the settings of the device, yeah, and you have network attributes. Yeah, how does the network react? Is there any problem in the network forcing, for example, players to rebuffer and stuff like this? This we wanted to check as well. Okay, so we came up with a framework for this project, measurement framework, which is established and is used to do the automated testing and measurement of streaming devices. Yeah, and we equip, for example, players with a special worker, SDK, which we integrate. As well, in the first generation of the EcoFlow project, we have contributed with this framework and generated the data for the project. So then we have an external measurement unit, yeah, as well, with an piece of software which is controlled, which can be controlled remotely. Then we have a control and user interface to use the whole system, and then we have a bunch of backend components for the automation of the measurements. Yeah, and for content creation, if we do repetitive tests using different encoded content, for example, and then we have a streaming analytics service that collects all the results, as well measurement results. But this is very important, the whole measurement setup. Yeah, so the complete description in which states the device was during the test, and which content was used, and so on. So to be able to replicate the test at any time in the future. Okay, yeah, and then we have run many of those tests. Yeah, so it's a job-based approach. Yeah, we have generic jobs defined, which result in multiple executions. Those executions are one per parameter combination. Yeah, and as you can imagine, and saw on a previous slide, the combination can explode. Yeah, so it's very important to keep all parameters constant and vary only one parameter to generate streaming session data that can be then compared, and the analysis on a specific value can be done. Yeah, I will skip this slide here. Of course, we have done measurements on mobile as well. And to second maybe one of those statements done before, in our measurements, we saw that bitrate or resolution when it comes to big TVs does not really matter much. Yeah, so basically what you see here is the signature of multiple measurements done on one OLED device. And the major factor here, so we have groups of graphs here. Major factor here is the fact that in one set of tests, echo mode was turned off. Yeah, and in the other, the echo mode was turned on. So as Ben already said, usually streaming is done using some decoders. Yeah, decoders can be equipped on those devices here. So just a thought experiment, we cannot expect from a TV saving a lot of watts. Yeah, when decoding is done within few watts. Yeah, so that's the reason. So major factor is here the display and the different modes in which a device can be. So echo mode works. This is one finding. So not so surprising, but in our field test, which we conducted during the last year, we found out that many users don't have it enabled. So more and more TVs are equipped with the Echo Mode on by default. But some users are switching it off, and in our finding, it was very surprising that many devices were not using Echo Mode. For sure, it's very legitimate to consume content in very good settings, which are very bright and HDR and the best experience possible. But the question is, should it be always like this? So I always make the comparison to a restaurant. I don't go every day to a restaurant, to a expensive restaurant. From time to time, yes. So when I watch a very good movie, the experience should be, of course, very good. But consuming streaming on a day-to-day basis, like we do right now, or scrolling through some social media feeds, the question is, does it has to be high res and best settings? So maybe an programmatic access to device settings would enable applications more than to control or to advise or give hints to the user for a more economic viewing experience and viewing in the end. Okay, in the end, we collected the data, of course, to generate models, regression models, to be able to predict on certain panel types with certain dimensions, different parameters, predict the consumption. And this is one of the outcome of the project, that we have now this models trained, which are becoming more and more accurate with the more measurements we feed in. And then the next thing is, and I will conclude then, is that we have using this model to integrate it in a offering for consumers. And this offering is described here a little bit technically, but basically using LLMs to get the request from the user in a very natural way. User might ask, I'm watching this movie on this device, what is my consumption? And maybe what can you please suggest me to reduce the consumption? And we are using our regression model and a multi-stage LLM approach here to get the user a better, eco-friendlier using experience. Okay, this is described a little bit here further. The only addition here is that we have fed into our models the manuals, TV manuals, to make the activation of the Echo Mode more easy, or support the user to activate the Echo Mode. So this is the basic idea here. On the one hand, predict the consumption. On the other hand, provide needed information to set the TV in a good energy preserving mode. Okay. This is some slides on the Whattlify solution. And then we, of course, as a next step.
Martin, can I just maybe ask you a bit on timing and so on? So don't rush it, but just let's make sure that we because
this is basically my last slide, and I will conclude. So the framework is as well being used to measure encoding. So it's the same worker concept was used to measure software-based encoder and hardware-based encoder, and the same idea here. Some results we have derived that, of course, if you change parameters, energy footprint is different. And that's basically all. Thanks so much for your attention, and sorry for taking too much time. Happy to answer open questions.
Yes, thank you, Martin. So no worries. I think we're okay in time. I just want to make sure that we don't enter another subject with another 5 minutes. All good. So let me check if there's immediate questions for Martin.
I cannot see the chat, so it would be good if you can read it.
Yeah, there's one question from Ben. Ben, maybe you go directly ahead and ask it.
Yeah, so yeah, Martin, we found the same as you showed that echo mode seems to be more effective on LCD than on OLED. I have ideas why that might be, but I wonder if you have an explanation why OLED echo mode is less effective than LCD echo mode.
Yeah. It really depends as well on the measurements you conduct. So on the content, so you have to check the full picture. Usually OLEDs are more or reflect the type of content more, and yeah. So we don't have now a 100% conclusion why this is like that, but it's one sign that content is here the factor that needs to be thought of.
Okay, good. I just recognized that my camera is not working. I had some resetting, so I apologize for this, but you can hear me and many people know me, so it's not interesting to see me. Let's enter a bit into the larger discussion. So I would invite that we maybe open up a bit of a panel and feel free to switch on the camera for the people who are the speakers. And let's just check.
Thomas, can I ask? I mean, Martin took a lot of my time. But
sorry.
Yeah, we have you as well. We still have the ad break from 5G Mac. Sorry.
I'm gonna put my 5G Mac hat on so it doesn't
Daniel,
too
go
much
ahead,
fun.
please.
Yeah,
please.
no,
please.
I'll be quick.
Apologies. Go ahead.
All right. Okay, you should be able to see them. I'm going to be quick. As Thomas said, we want to have a discussion in the end. But I wanted to briefly introduce the 5G Mac reference tools as well. So I'm Daniel Slavi. I'm also with Fraunhofer. But as I said, I'm going to put my 5G Mac hat on right now. So I'm the development chair or chair of the development group in 5G Mac. And we think the 5G Mac reference tools are really valuable also for the upcoming discussion, because this can be your playground to actually try things. And what we are doing in 5G Mac, and especially in the 5G Mac reference tools, is we take specifications, for instance, from 3GPP, and we bring them to life. So we want to catalyze their adoption. We basically take the specifications and we start implementing them. And what we have in place in 5G Mac is really a great model because we have experts from the SDOs in our code. For instance, Richard is here today, Thomas is here today. So we have this kind of feedback loop in place where we have developers doing the implementation, and they can go back to the experts from the SDOs, ask questions, and then provide immediate feedback. So for instance, if I have a question, I just go to Thomas, I go to Richard, I ask them something. Maybe I'm even more confused afterwards, but I get all the information that I need. So this is one thing that we want to do in the reference tools, but the reference tools are also something that you can use as a starting point for a commercial application, or if you're a researcher, you can use them as a starting point to write your paper and have some baseline implementation, some playground that you can try out things. And we have a very IPR-friendly model, so lots of lawyers are very happy with that. So you can contribute back to the reference tools pretty easily. And we have tons of contributions. You will also see this in the projects. So we have many companies actually contributing to the reference tools. So what are we doing exactly in the reference tools? And this is just a high-level overview of all the activities. I checked this morning, we are at 55 different repositories on GitHub. So that's great to see. It's more work for me, but still it's great to see and have all these contributions. And we are going to focus in the upcoming few slides on the first aspect here, streaming media delivery and data collection, because we think, and I mentioned this in the beginning, the reference tools can really be a starting point if you want to try something out, especially also related to reporting green streaming metrics. So the first thing that I wanted to very briefly highlight is the 5G media streaming architecture and what we have in place there. And this relates a bit to what Julian presented. So the diagram on the right side should look kind of familiar to you. We saw that in the presentation by Julian at the beginning of the workshop. I don't want to go into details. I just want to mention that the components you see here in yellow are related to the 5G media streaming architecture. So we have additions on the core side with the application function and the application server. And on the client side, we have a media player, we have a media session handler, and the 5G media streaming client. So all of this is something that we have in place today in the reference tools. We are relying on certain other open source software, for instance, Nginx or the Open5GS core and the ExoPlayer on the client side. But the whole system, as it looks, as is today defined in the specification, is implemented based on release 17 right now in the reference tools. What you will find if you look into 5G media streaming are certain additions on top of classic OTT streaming. And we highlighted two very relevant ones here today. So the QE metrics reporting and the consumption reporting is really something that could serve as a starting point to report any metrics that are related to energy consumption and green streaming. So right now, as of today, we support for QE metrics reporting the NXD metrics from the DASH specification coming from the CDPP DASH. But sorry, there was an automatic slide change here, but also consumption reporting metrics, such as, for instance, how long a DASH representation has been played. We are also looking into release 19 features. So there I want to highlight Camel Media client data as one way or another way to report metrics from a client to a server and then consume them on the server side and do your evaluation on the server side. So CMCD is part of CDPP release 19, at least the first version. And they're also looking into version 2 of CMCD right now, might be coming in, and Thomas and Richard know this better than me, 20 or 21. These are all the repositories that we have in place. Again, I don't want to read through them, but everything is available on GitHub. So I mentioned these 55 different repositories. Some of them are related to 5G media streaming. They are listed here. So everything that we do is typically immediately available on GitHub. You can try it out. We have tutorials on our documentation website that Jordi spent a lot of time on working and making it as easy as possible for people to get onboarded. And yeah, you can do modifications to the code base. You can fork the projects. Anything is possible as of today. Final, it's called a technology also related to what we discussed today, UE data collection reporting and event exposure. So that's another way of kind of reporting data from a client component to a server side or core side component. And then we get an additional benefit of having some kind of pub/sub pattern in place here. So essentially, we have a framework for data collection and reporting. In this case, what we did as an implementation is we rely on release 18 features that we implement. And we have a service provider library in place that you can plug in arbitrary application functions. So we have a standalone data collection application function as a reference, and we are working on integrating that into the 5G media streaming application function. And another target could be the energy information application function that Julian mentioned today. So as I said, it's a pub/sub pattern. You have different components involved, but essentially it allows you to report data and publish that to other event subscribers. This is the single repository that is important for this kind of setup. So again, you can find everything on GitHub, and we rely on certain other open source technologies for the implementation. Final slide. So that was really quick, I know, but you can find all the information on our website. We have documentation available on GitHub. We have people in our Slack channel answering questions, happy to receive any feedback. We have a dedicated Slack channel for all of the different repos. We do our announcements of upcoming releases and release candidates on Google Groups. And then we have weekly developer calls for everyone who's a 5G MEC member, but also the last Friday of the month is reserved for everyone who is not even a member and who wants to join and listen and get an understanding of what we are doing right now. So we have these public Friday calls every last Friday of the month where everybody can join and ask questions and provide feedback. And yeah, we even work sometimes over issues together, just trying to fix certain setups on certain machines. Otherwise, if you have any questions, I suggest the main starting point would be Eva and Jordi for contact, but you can always contact me as well or reach out to people on Slack and on GitHub directly. Thank you.
Okay, good, Daniel. Thank you. So now any questions for Daniel right away? No, good. So then let's open up the panel. I ask again, switch on maybe the cameras if you're able. Let's be part of the panel. The first thing I want to just ask into the crowd, like in particular Ben and Julia, who were basically part of the initiators. Did you learn anything today that you found interesting, Ben, Julia, that maybe helps you a bit in the work you're doing? Maybe from other orgs and so on and so on. Just checking.
Yeah, well, it was really cool to see some of the things that I thought being confirmed. I got some confirmation of data points from the Fraunhofer presentation. I found that really interesting. And to see that there is some kind of convergence now on the way we kind of model things, apart from the Austrian university one, which kind of pushes the whole network out. Everybody else seems to have the same kind of vision. I don't know if that's a good thing or a bad thing when we all converge.
Julia?
Yeah, on my side, I'm happy to see that there is already quite a lot of work in the streaming ecosystem working on the energy efficiency, so it's good. But I think we can also see that we have an issue to have metrics on the end-to-end delivery chain, so no one has solved this issue. I think there is place to work together on this, or at least we should work together to check how we can progress on this.
Okay, good. So then let me bring in Christian and our colleague from ATEM. Let me just check Lucas. So I wanted to understand because, but more from a perspective. So you have these research projects, and I think there's a lot of interesting finding. But you're also close to obviously products that are or services, right? So how much is this going to be moving into, let's say, 10 products? How much can you get access to energy-related information from a product? And obviously not sharing details, but understanding, is this something that is imminent, and is it what customers want? And also for Bitmoving, a bit of perspective, is this moving in there, or are we basically still as a research level?
So basically, the customers themselves were asking for this kind of information being displayed in our monitoring solution. So it's not currently available in the general availability version of our monitoring solution. But at the end, yes, that's the aim of it. But once again, monitoring and assessing the power consumption of our products is just a first step into our end goal, which is to reduce this consumption. But yeah, so to quick answer, yes, at the end we will for sure make these metrics available in our monitoring solution.
From our side, it's mainly research based, Thomas. So that it is. In Bitmoving, they have they had this video developer report that they issue every year, and then there was a question about energy consumption, and the response was always like, "Oh yeah, sure, we want to have this, but we don't want to pay for that." So this is so. I think from that perspective is unfortunately a bit discouraging in terms of what the customers are actually needed. I cannot confirm what has been just said before. Unfortunately, this is a bit interesting from my point of view. We always thought that, like in Europe, when my colleagues from Bitmoving discuss at ABC from the people, there is a bit more interest in that compared when asking the same questions at NAB. Other than that, it's pure research interest at the moment. But I think we have also the tools in place, so at least for encoding, to make this available and integrate this in the products once there is a big need from the customers, or alternatively, and I can remember this was also part of the greening of streaming initiative. There comes enough pressure from the regulation side, from like government, EU, and stuff like this.
Okay, thank you, Christian. Ben has a question.
No, it's just to add to that discussion. We're not vendors, of course, but I think one of the issues, and we as an industry and groups like people around this call today, should be cognizant of the fact one of the issues here is greenwashing versus greenwashing kind of thing. Because what happens is there's a desire to do something, and some of the early adopters will go and say, "I'm doing this, it's green." And then it turns out to be a bit of a greenwash, because actually when we look further, it didn't actually save that much power and it generated a problem elsewhere. And some people have burnt their fingers. So I think we've got to be very careful that when we spot sort of like unintentional greenwashing, we be gentle about that and say, "Oh, by the way, that's not quite true," and not say, "This is all rubbish," and you're then obviously real greenwashing we have to combat openly. And I think if we have the right attitude to that, it will help the vendors be more, because I know some of the vendors that are sitting on various things, that they're suffering from greenwashing. They're scared that if they push them too loudly, too fast, they might get negative blowback. So I think we've got to really encourage the vendors who have anything that might help, and maybe they can bring things out saying, well, this kind of we think helps, and then as an industry we'll help them find out if it does help. We've got to help each other. We've got to do this as a community. And I think if we say, well, it's the vendor's responsibility, it'll just slow things down by a few years.
Okay, let me just include also Marisol and Martin quickly for a question. Then we open up and then we try to wrap up. We have 10 more minutes. Marisol, you're in the IETF global organization. How prominent is this on the agenda, like metrics collection in the IETF being a global organization? Is it something that is pushed by smaller companies, or is it something that is a broad interest, let's say it like that?
Let me just say that I'm a contributor in IETF, but I'm not representing IETF here, right?
Yeah. No, I understand.
The SDOs. But what we see in IETF is a big push from operators, right? The ones that are vendors are listening more at the moment in IETF. Before IETF has more presence on vendors, now is shifting to operators, and they have a big voice. Right, and there are many working groups, including the Getting Ready for Energy Efficiency working group, more push for, the ones asking for new drafts, new standards are the operators, and this is something that is pushed right from the area directors as well.
Okay, thank you. So Martin, a question for you. You had something interesting in there, which everybody probably has nowadays, but you have concrete AI, right? So now the old question about AI, is it going to be, now we know that with AI, the energy consumption that is around is actually increasing globally, right? So everywhere. But you presented it more as it might be an energy saving. So how much are we basically balancing between, so AI in workflows, at the encoding, in the distribution? So do we expect that it's going to be helping us, or it's going to be just amplifying the problem we're having? So any indications there? And I don't expect an answer, but just made a bit of a perspective.
Yeah, that's true, of course. I mean, all the data collection, all the model training, that does not come for free, right? It introduces new costs, new consumption, new energy footprint. But we think that if you once have a solid data set, which is valid, and ideally by vendors providing access to metrics, it was already mentioned, metrics we need, so that we really can put numbers, real numbers on the consumptions, on the frames. Something like, what does a frame in video streaming cost in terms of watts, from end to end? Something like this, something like a currency like this would maybe help to understand better the situation. But yeah, you are right. as well, we have a lot of servers right now generating video, here artificial video clips and funny stuff, which we all love and laugh about. But this is now another source of consumption. So we have everyone has to think maybe or. Yeah, hard to tell. Yeah, we have another new source of energy consumption, generated content for sure. But
Thank you.
yeah,
thank you. So let me just check questions from the audience or the panel. Daniel, so I open for panel questions now. So first Daniel, then Richard. Go ahead.
Yeah, this is maybe more a question also to the panel, but how much do you think we need to educate people? And I give you an example. So we just recently bought a new TV for my grandma. And when I unpack that and I get the remote, I have like 5 buttons to start Netflix, Prime, I don't know, Hulu, which I don't need in the end, which she doesn't need. But there's no button to actually switch between the different modes of the TV, right? So you cannot easily switch to like the energy saving mode or whatsoever. So I think it's also a bit of an issue that people are not aware that they're not in the energy saving mode on their TV, and that they might save not only energy but actually cost. So if you show them something like with this mode, you save, I don't know, €1 per hour. I think that is something that would work, and I think not many people are aware of that outside of these specific rounds.
Okay, anyone wants to answer, Ben? Maybe you guys did anything like regulation, remote controls, and so on, awareness for end users?
No, well, as I said, we're hoping to be much more precise with echo mode and find a way of perhaps labelizing it. I'm using a French word, but to put it to standardizing it, so that we could then go to regulators and say, you know, to use echo mode, it has to be, that would be one error. But in terms of communication, you're completely right. There isn't any way. There was a discussion earlier on in the chat about programmatic stuff, and I made a suggestion. I used to work at Ultra HD Forum, and there's a thing called director mode, which is nothing to do with energy saving, but it's when a film distributor wants to say, James Cameron, he made this movie in this way, and he wants you to watch it in this way, and so therefore he set the TV settings, and they are programmatically, they go all the way through the network right to the TV. And then you as a user have a little pop-up that says, we suggest you watch this in director mode. There's various settings. So there is a way of doing it with director mode. So there was just, I had a chat with Ian in public there. We could do that with energy saving mode. The technology's there. We just have to piggyback what those guys did for artistic intent and do it for energy.
Yeah, I mean, that needs an end-to-end eco-chain support. So the device manufacturer, or basically it needs to be passed through and the device manufacturers need to support it. But that's similar, right? So you expose this information. Richard.
Oh, there we go. That's the right button. Yeah, thanks. So I was just trying to think back to what we've seen over the past couple of hours, and I think almost the first slide that Julien presented in the orange presentation showed a little pie chart saying that the energy consumed by the network is, you know, relatively modest and is dwarfed by the energy consumed by the end devices. And then later on in the ATEM presentation, we saw some data almost saying the opposite, that actually the dominant consumer of energy is the network and the end device is negligible. So yeah, I mean, how am I to reconcile this, and what needs to be optimized? I mean, do I need to be optimizing the energy of the network, or do I need to be concentrating on, you know, making the eco mode better in the end device? What am I to make of this conflicting information?
Yeah, maybe we should invite Julien and Lucas to basically check the data and understand where the differences come from. Julien and Lucas, maybe you have an idea. If so, you're muted.
Well,
on my side, this is coming from ITU and World Bank report. So I'm quite confident
So-
with those figures, but it's not energy consumption, it's carbon footprint. So maybe this is the first reason, because carbon footprint by manufacturing some devices is more important than for the network. So.
I've been following that pie chart for the last 6 years or so, and it started with the Shift project, and the very latest sort of highly credible study comes from the BBC, Richard, which was like 4 or 5 months ago, I think it was published, and that says 92% of the problem comes from end devices. Going back to the network side, the ADEME in France, they were published twice in a row in 2020 and 2022. They published a study saying the network was responsible for 5 or 6%. And then they published a study in late 24, early 25, putting it all the way up to 20%. And oh my God, what's gone wrong? Has somebody made a mistake? Said, no, because the previous studies were about all of digital services. The latest study is just video streaming, which, But one thing I'd like to say from greening of streaming's perspective, we recognize there is an industry consensus which puts the network somewhere between, let's say, around 10% of the problem. It puts the end device somewhere in the sort of 70s or whatever. That includes the router. But I'm treading very carefully here because I'm really keen to get someone like Julien Orange to join my organization. So I've got to be very nice to them. But the issue is, if you look at the energy consumption of a network, incumbent, so let's not talk about Orange, let's talk about BT in the UK. They use almost 1% of the British grid's energy. I find it very hard to reconcile that with the fact that they're using 1% of the energy of Great Britain, and they would be and their network has 70 to 80% of what it carries is video, and that so that in the video consumption pie chart there would only be 4 or 5%, which some of the studies say. Now I find that hard to believe, but maybe it is. I'm not saying it's wrong, I'm just saying it's difficult. And I'm saying when we look at those pie charts, I take them with a grain of salt, because all the stuff all the presentations have repeated today, we have a pretty good understanding of what's going on the end device. We know how terminals work, how end user devices works. We can physically measure them. We know how many are out there. So we're comparing that with something that is much more opaque. So whether it's the CDN part, the ISP part, they're so opaque, and then we're trying to make a pie chart comparing things. The numbers were created in a completely different way. So all the research has been done. I applaud it. It's great. Somebody had to break the ice and do it. But we're not happy with the situation at the moment. When we see those pie charts, I say, great, another one. I hope it's better than the last one. But just look at how they've evolved over the last 6 years. You know, they sort of go all over, which shows that we're comparing things that we have completely different ways of capturing the energy of, you know. So there may be a time when greening of streaming has its own pie chart. If that happens, it won't be for at least another 2 years. That's in the best possible case, because we have to actually go and physically measure stuff inside a network. And so far, we don't have a network operator ready to do that. We're doing it with the CDNs bit now. So we'll have the real data from CDNs. And a final point to say on that is there's a big attribution problem, is that the TV, when you turn it on, it's just used to watch TV. As soon as you go to your home gateway, that's used for other things too. And then when you go to an IP network, like one run by Orange, it's used for a million things, and running video is just one small part of it. So there's a great attribution problem, is how we attribute the energy it's used, which explains why there's so much variation.
Okay, I would like to thank everyone. We are over time. I also want to be conscious that people have schedules. I know Ben needs to run to another call.
Yep.
So we will have not made a conclusion here. My suggestion is as follows. We share the data that has been collected. I think it was also good to meet people, to understand who is interested in this, have a discussion. So there's a bit of a community. We will publish the slides. We will publish the recording. We will publish some notes. I also expect we will ask you a bit of a survey on how did you like it, but also should be the follow-up, what are concrete issues that need to be done. And based on this, we come back to you and the larger community with some follow-up, be it another session like this, maybe with very concrete topics, or big suggestions to do something in greener streaming, or an invitation to IBC to maybe have something and so on and so on. So we will digest this. So please stay involved and help us to basically progress the work.